In this video, we're going to learn the last two exponent rules, which is what happens if you have a negative exponent. So far, all our exponents have been positive. And what happens if we have a zero exponent. So your objectives is that you can apply the negative exponent rule to algebraic expressions, you can apply the zero exponent rule to algebraic expressions, and then you can apply all the exponents rules simultaneously. So far, just to review, these are the exponent rules we have learned. We have x to the m and x to the n. So when we have the situation, same base, and we're multiplying, remember you add the exponents. We have the quotient of the power rule, which remember it means division. Here we subtract our exponents, so we kind of think who has more. And then the power to the power rule, which was the last video, we multiply our exponents. Alright, so we're going to take a little exploration or discovery to figure out what we do with negative exponents. So look at the situation. If I have 2 to the 5th power, well, 2 to the 5th power is 32. 2 to the 4th power is 16. 2 to the 3rd power is 8. 2 squared is 4. And 2 to the 1st is 2. Well, notice what's happening from here to here and so forth. What pattern do you notice? So think about it a little bit, and hopefully you come to the conclusion. We'll go from here to here to here. You are dividing by 2 each time. So if I continue this without typing in 2 to the 0 into my calculator, well, 2 divided by 2 is 1. Well, in mathematics we have a lot of patterns, so we can continue this pattern and go 2 to the negative 1. Well, here 2 to the negative 1, if I divide 1 divided by 2, is 1/2. If I go 2 to the negative 2, do the next one, 1/2 divided by 2, if you cut a half in half, that means you only have 1/4. And I can do it one more time. 2 to the negative 3 is divided by 2 is 1/8. Well, if you think about it, what 2 to the first, or 2 down here, means this is 1 over 2 to the first. Down here, 4 is 2 squared. This is 1 over 2 squared. And then this is 1 over 2 to the third. Notice it did not, the negative exponent did not make it negative. It simply just made it smaller. Or another way to think of it, right now this 2 to the negative 1 is in the numerator. You don't see a fraction, but all numbers are always in a fraction. We just put over 1. It's invisible because we don't need to write it, because anything divided by 1 is itself. So these are all over 1. Well, what happens is they kind of just flip. They take the entire expression, it moves down to the denominator, it was in the numerator, and then what would be left there would be a 1, because there's always a 1 in place. The 2 to the negative 2 got moved down. So let's look at the next example and see if the same thing applies. In math, we like to make sure with patterns that we can reproduce it, and make sure the same thing goes with science. You always, if you have an experiment and you get a result, you should be able to reproduce to make sure it's true. Well, 10 to the 5th is 100,000. 1 with 5 zeros. 10 to the 4th is 10,000. 10 to the 3rd is 1,000. 100. 10. Well, if you kind of notice what's happening from here to here, you might say, oh, you're just losing a 0. But like the previous example, what are you dividing by? Well, to lose a 0, you divide by 10 each time. So if I continue that pattern, 10 to the 0 means you divide by 10 is 1. Notice right here, in both cases, 10 to the 0 is 1. And the way I like to think of the 0 exponent, 0 means I want it to be if you take anything to the 0 power, it's always going to equal 1. And 1 just means it's just, I don't want anything, I just want it to be 1. So anything to the 0 power is 1. I don't care how big it is. You can have something with a whole lot of junk, but if it's to the 0 power, it is 1. It is kind of its original, the most basic form is 1. The Alice activity we're going to do will be a little clearer why anything to the 0 power is 1 when we get through that portion. And then continuing the pattern, if I have 10 to the negative 1, this comes out to be 1 over 10, divide by 10. 10 to the negative 2, that's 1 over 100. Divide by 10 again, that's 1 over 1,000. And again, I can write this as 1 over 10 to the first. This is 1 over 100 is 10 squared. And 1 over 10 to the third. So we see the same thing happening that we had in the previous, where we're taking what's in the numerator, the negative exponent, is moving it to the denominator. So the negative exponent, it moves, it does not make it negative. With exponents, since we have all positive bases, will never be negative unless we have like a coefficient or something that is negative. So the 0 exponent rule, I just explained, anything to the 0 power is 1. No matter how big, how small, it's always going to be 1. The negative exponent rule, you need to think it moves the base. An exponent. Alright, so moving, I mean it switches from either the numerator to denominator, denominator to numerator. So x to the negative n. Right now this is in the numerator. It's over that invisible 1. So if that's a negative exponent, it moves it down to the denominator. There's always a 1 in the numerator, so this is x to the n, and notice it made it positive also. You can go plus n. Now if it happens to be in the denominator, well, it needs to move. Well, it's in the denominator, so it can't move to the denominator. It needs to be shifted up to the numerator and change to positive. And this really is x to the n over 1, but anything divided by 1 is x to the n. Alright, so let's look at a few examples dealing with this. This seems like one of the hardest rules for students to understand, but once you get the hang of it, it gets pretty easy. You just got to take time and think. It's not making it negative, it's just moving. So I have k to the negative 4. Right now it's in the numerator. The negative exponent, its job is to move it to the denominator. Well, k to the negative 4 becomes k to the 4th in the denominator, and there's always something in the numerator, so we put a 1 up there. And b, y to the negative 6 is in the denominator, so it needs to move to the numerator. So that's y to the 6, which 1 got left in the denominator, but anything divided by 1 is just y to the 6. So on C, again, negative exponents move. Positive, they're just fine and dandy where they're at. They don't need to move. So a to the 8. Right here, this has a positive exponent. And right now, this entire expression's in the numerator, if you write it as a fraction. So a to the 8th stays in the numerator. The b has a negative exponent, so it needs to move. It's getting kicked out of the numerator. And c to the negative 6 needs to move to the denominator also because it is negative. Another way to think of it, I've told students, you never want somebody with a negative attitude. So if you have somebody with a negative attitude in group, more than likely you want them to leave the group. So B and C are both negative, so you want them to leave. You want them to go to the bottom. So on D, a very common mistake has on D, a lot of students see 5. Now 5 is a negative number. Its exponent, remember everything has its own exponent, is 1. So it does not move. So negative 5 stays in the numerator. It has a positive exponent. But m is negative, or negative exponent, so that goes to the denominator. And n is a positive. It's a positive variable, positive exponent, so that stays on top. On E, G, its exponent is not negative 8. Everything has its own exponent. If you don't see it, it's just one G. So G stays. H is negative. Oh, we want to kick it out. We don't want it part of our group. But K and J both have negative exponents, so they both need to be kicked out of the denominator to the numerator, to K to the 5th, J to the 9th. That's my final expression. Again, order does not matter with variables. We just want those numbers in front. Alright, so now we're going to kind of apply our rules. I always like to make my exponents positive. First, you do not have to. You can apply your product of power rules. It's all up to you. There's really no specific order operations when it comes to exponents. So you kind of do what you need to. And I can show you in this first example that they come out being the same. So I'm going to make my exponents positive. I just find it's easier to deal with positive numbers than negative numbers. So f to the 5th was a positive exponent. This was negative, so that one got kicked to the denominator. Now I have two bases that are the same, so I need to simplify. You can only have one of every base. So I have, this is my quotient. I have 5 f's in the numerator, 8 f's in the denominator, and that is f to the 3rd. Now the other way you could have did it, you could apply the product of power rule because we're multiplying. Add 5 and negative 8, so that's f to the negative 3. Well, my exponents need to be positive. So that's in the numerator, it's going to get kicked to the denominator, so it's f to the 3rd. So again, both of them are kind of two steps, but you get the same result, and order does not matter which one you want to do. I, again, personally like to do exponents, or the negative exponents first. So here I have this expression. I'm going to make everything, all my exponents positive. You have a squared stays. Well, b to the 3rd is negative and needs to be kicked to the denominator. A to the 6th and b to the 3rd. Alright, so I can put together, I have 8 a's in my numerator. And then I have 3 b's on top and 3 b's on the bottom. So that's 3 on top, 3 on bottom. They cancel. So I'm actually, these both become 1. So I'm left with a to the 8th. On H, 3 has a positive exponent. 3 would not move. T has a negative, this one has a negative exponent, so it needs to be kicked to the numerator. And that one also needs to be kicked to the numerator, t to the 4th. I'm not done yet because I see 2 sets of t's. So I have 3 t to the 6th. So on I, again, I like to make all my exponents positive. And think to yourself, because students are tempted, oh, negative 6, oh, I need to move it. No, it's a negative number. So that one gets to stay put. And v squared gets to stay put. 3 and v get to stay put. The negative 9 does not go to the 4. It's only to the v. So that is 4 over v to the 9th. I am not done, and I know for 2 reasons. All my exponents are positive, so that's great. But I have numbers, and we're multiplying, so I have negative 3, or I have negative 6 times 3 times 4, which gives me 72. Negative 72. And then I can look on the top. I have 3 v's on top. I have 9 v's on the bottom. So who has more? Well, I have more v's in the denominator than I do in the numerator. How many more? That's v to the 6th. Alright, last examples. Again, I'm giving you a bunch because students tend to struggle with these. Let's skip K to kind of save time, but we'll do these 3. So again, I like to move. You can apply your rules first. It doesn't matter order, but I like to make everything positive. So m to the negative 4, that one gets moved to the denominator. n to the negative 12 gets moved to the denominator. P to the 7th, that has a positive exponent, that stays on top. M squared goes to the denominator. N to the 8th goes to the numerator. And P goes to the denominator. Alright, so simplifying, I have 7 P's and 1 P, and they're dividing. So I have 1 that simplifies out, so that's P to the 6th. Again, feel free to write this out as repeated multiplication if that helps you. Over here, I have my n's. I have 8 on top, 12 on the bottom, so I have 4 more n's in the denominator. The other ones simplify. And then I have 2 sets of m's in the denominator, so that becomes m to the 6th. 4 here plus 2 more. L. Alright, so here we have that power rule. This one I actually like, well, to distribute first. So I have 3 to the negative 2 and 4 to the negative 2. And then, because they both have negative exponents, they need to be flipped around. And then I need to calculate this out. 4 squared is 16. 3 squared is 9. And then the last example. So here I have a power on the outside. So I need to distribute. And again, you can write this all out if you need to. We distribute it to everyone. The 4 has exponent 1. That's 4 to the negative 3. M to the negative 24. We're multiplying our exponents. N to the negative 12. And P to the 9th. Again, I like then make everything positive. 4 to the negative 3. That needs to go down. 4 to the 3rd. M needs to go to the denominator. N needs to go to the denominator. And P, which is in the denominator, has a positive exponent, so that one stays. And then I have 1 on top. So I have 1. 4 to the 3rd is 4 times 4 times 4, which is 64. And then everything else is good to go. We don't have any other extra bases to combine. Alright, so that is it for your exponent rules in this video. You have negative exponents. Again, all it does, it moves. Okay, if it's in the top, it goes to the bottom. Or it might go from bottom to top. Alright, zero exponents, anything to the 0 power is 1. Again, negative exponents does not make the base negative. Again, remember to do your reflections so you get credit for watching this video.